Welcome to Thought Frontier.
Welcome to the deep dive. Today, we're diving into the world of quantum computing. We've got a ton of research papers, articles, even a peek inside a quantum lab. So get ready to kind of unpack what quantum computing is, why it matters, and where it's all headed.
What's really fascinating here is we're not just talking about faster computers. Quantum computing uses the principles of quantum mechanics to process information in a completely different way.
Yeah.
It's a huge leap forward. You could almost compare it to going from like an abacus to a smartphone, but with possibilities that are even harder to grasp, really.
Okay, so our sources all point to the qubit as the starting point, like the bits in our computers, but with this, quantum twist.
Yeah.
Can you help break that down a bit?
Sure. Think of a coin. A normal bit is like that coin laying flat, right?
Yeah.
It's either heads or tails. But a qubit, it's like that coin spinning in the air. It's not heads or tails until it lands. It's both at the same time. And that's what we call superposition. And that's what gives quantum computers the ability to explore so many possibilities all at once.
So by harnessing superposition, quantum computers could just totally outperform traditional computers on certain tasks.
Yeah, exactly. Like there's this article about Google's quantum supremacy experiment. Their Sycamore processor that has 54 qubits, and it did this calculation in 200 seconds. And get this, it would have taken a supercomputer 10,000 years to do the same thing.
Wow, 10,000 years to 200 seconds. That's mind-blowing.
So does that mean then that quantum computers are like the undisputed champs now? Well, at first it seemed that way, but there's a twist. Another article, How a Classical Computer Beat a Quantum Computer at Its Own Game, talks about researchers who figured out a way for a classical computer to actually beat Sycamore on that same task. So it's a real, it's a back and forth,
So even with all this quantum supremacy talk, it's not a guaranteed win for quantum computers.
Right. It's not so simple. It really highlights how important the algorithms are, not just the hardware. It's like, you can have the fastest race car, but you still need a skilled driver and a good plan to win the race.
Okay, that makes sense. So we've got these powerful quantum computers working with these strange rules, but they also seem, well, kind of finicky. They have to be kept super cold and they're prone to errors. So who's actually investing in this?
Well, it might surprise you, but it's not just research labs. We're talking big tech companies like Google, IBM, Microsoft, Amazon. They're all heavily invested in quantum computing. There are even startups like Rigetti and IonQ. Those are mentioned in the Why Quantum Computers Will Break Reality video. They're getting tons of funding, too.
So it sounds like there's this global race to develop this technology. What are the potential rewards that everyone's after?
Well, that's where things get really interesting and potentially disruptive. Imagine a computer that could break the encryption, protecting everything online. Like the IBM article talks about Shor's algorithm, which is a quantum algorithm that, in theory, could crack the codes we use for everything: secure communication, financial transactions.
Okay, that's kind of unsettling. Is anyone working on ways to prevent that kind of security breach?
Yeah, definitely. There's already this push towards post-quantum security. The video that mentioned Shor's algorithm, Why Quantum Computers Will Break Reality, talked about that. And companies like Apple, they're working on new encryption methods that are resistant to quantum attacks.
So it's like this race against time, trying to build a more secure digital world before these powerful quantum computers, really arrive on the scene.
Yeah, I think that's a good way to put it. But it's important to remember that code breaking is only one part of the picture. What really excites researchers is the potential of quantum computers to revolutionize fields like medicine, material science.
Wait, so you're saying quantum computers could actually help us cure diseases and develop amazing new materials?
Yeah, just imagine we could design drugs and materials at the atomic level. The Department of Energy, they have this article, DOE Explains, Quantum Computing. And they talk about how quantum computers could help us discover new catalysts. These are materials that speed up chemical reactions. And they could lead to, cleaner energy and new manufacturing processes.
Wow, so we're talking about potential solutions for energy, manufacturing, even medicine.
Absolutely. And there's more. The article, Quantum Computers Are Here. It explains how quantum computers could help us solve what are called optimization problems. This has implications for logistics, finance, even something like traffic flow.
Wow, we've covered so much ground already, and it feels like we're just scratching the surface of what's possible with quantum computing. But before we get into the specifics of those applications, let's take a step back. Who are the major players in this quantum race, and what are the potential risks and challenges? That's what we'll be looking at in part two of our quantum computing deep dive.
As we explore quantum computing further, it's interesting to see how it's not just a scientific thing, you know?
Yeah.
It's become this global race with some pretty big implications.
Yeah, it seems like everyone wants to be part of the quantum revolution. So who are the big players here, and what's at stake?
Well, we talked about the tech giants, right? Google, IBM, Microsoft, they're all putting a lot of resources into developing quantum computers. But there's this video, Race to Harness Quantum Computing's Mind-Bending Power, that really highlights the competition between the U.S. and China.
Oh, so it's not just about scientific progress. It's about like national pride and maybe even global power.
Exactly.
Yeah.
China is investing a ton of money. They want to be a world leader in this tech. And it raises some interesting questions about, the future of technology and innovation.
It sounds like a new kind of space race, but with qubits instead of rockets. What are the risks, though, if one country gets way ahead in quantum computing?
That's a really important question. Remember we talked about quantum computers cracking encryption. Imagine if a country had that power. They could disrupt global communications, financial markets, even, military operations.
That's a little scary to think about. It makes you realize this technology, it's exciting, but it also has a dark side.
Yeah, for sure. It's not just about who builds the most powerful quantum computer. It's about how it's used, who has access to it.
Okay, with all this talk about potential risks, are there any, actual benefits we can expect to see anytime soon? Or is it all just code breaking and global domination?
No, not at all. Actually, one of the most promising areas is medicine.
Oh, okay. How could quantum computing, change healthcare?
Imagine being able to design drugs and therapies that are tailored to your specific genes, or simulate complex biological processes so we can really understand diseases like Alzheimer's, cancer in a way we never could before. That's the kind of impact quantum computing could have.
That would be incredible. It sounds like something out of science fiction, but it's actually happening.
Exactly. And it goes beyond medicine, too. The quantum computers are here. Article mentions optimization problems, things like logistics, finance, even, traffic flow. Those are all areas where quantum computing could really make a difference.
So it's not just about replacing our current computers. It's about quantum computers working alongside them, each doing what they're best at.
Right. It's about using the strengths of both technologies to solve some of our biggest challenges. Like, think about it. Finding the best route for deliveries that could save businesses money and time, reduce fuel consumption, even have a positive impact on the environment.
So we're starting to see the bigger picture here. Quantum computing, it's not just a competition between countries. It's this powerful tool that could help us solve complex problems and even improve our lives. But there are risks too. It seems like navigating this new landscape, it requires us to be really careful to think about both the opportunities and the potential downsides.
Absolutely. It's so important to have these conversations. We need to approach this technology with a sense of responsibility. Think about the long term.
Well said. As we continue our deep dive into quantum computing, we'll be exploring not just the tech advancements, but also the ethical considerations and how this could impact society. Stay tuned for part 3 of our quantum deep dive, where we'll tackle the challenges, the opportunities, and the big questions that lie ahead. So we've talked about this race for quantum supremacy and the incredible potential, but what are the big challenges? What do we need to overcome before quantum computing really becomes like mainstream?
Well, one of the biggest things, and it's something that comes up again and again in all our sources, is scaling up. We've seen what quantum computers with, a few dozen qubits can do.
Yeah.
But for those really complex problems, we need systems with hundreds, maybe even thousands of qubits.
And it's not just about adding more, right? They have to all work together reliably. That's where error correction comes in.
Exactly. Qubits are incredibly sensitive. Like the tiniest change in temperature, even a stray magnetic field, it can mess them up and cause errors.
So how are researchers working on that? Is there a way to make these qubits more, robust?
The IBM article, What is Quantum Computing? It goes into some of the approaches they're trying. One way is to develop better error correction codes. They're like algorithms that can, detect and correct errors as they happen.
It's like a spell checker for quantum calculations. But even with that, it sounds like we're still pretty far away from having these like stable, large-scale quantum computers.
Yeah, it's a long-term thing, but
Yeah.
there's a lot of buzz around this new idea called quantum-centric supercomputing. IBM mentions it in their article too.
Oh, what's that?
It's basically combining the power of quantum processors with the reliability and flexibility of, our regular supercomputers.
So not replacing our current systems entirely, but working together.
Exactly, kind of a team effort. It could be a way to really unlock the potential of quantum computing, Let us tackle problems that are just impossible right now.
We've talked about a lot of potential benefits, but one video, Why Quantum Computers Will Break Reality, takes it even further. They say quantum computers could help us unlock the mysteries of the universe.
It sounds crazy, but it really shows you how powerful this technology could be. Imagine being able to simulate, the behavior of molecules and atoms with incredible accuracy. That could revolutionize fields like materials science. We could develop completely new materials with properties we've never seen before.
And beyond materials, what about like our understanding of the universe itself?
That's where it gets really mind-blowing. Quantum computers, they might help us understand those fundamental laws of physics. Things like dark matter and dark energy. They might even help us understand, consciousness.
Wow, from optimizing traffic to the secrets of the universe. It's amazing to think about all this. But let's come back down to earth for a minute. What are some of the things we need to think about as a society as this technology develops?
Yeah, that's a really important point. One of the big concerns is making sure everyone has access to this technology. If quantum computing becomes the key to scientific breakthroughs, to economic progress, we have to make sure those benefits are shared.
Right. We don't want to see a quantum divide where only certain countries or companies have this power.
Exactly. And there are, ethical considerations too. How do we make sure quantum computing is used for good, not for, harmful things? How do we protect privacy when these computers could potentially break any encryption?
These are big questions.
They are. And it's so important to have these conversations now while the technology is still developing. We need to think about what kind of future we want with quantum computing and work together to make sure it benefits everyone.
Well said. This deep dive into quantum computing, it's been quite a journey. We've covered the science, the global race, the amazing potential, but also the challenges and the responsibilities that come with this technology. As we wrap up, we encourage you to stay curious, stay informed, and stay engaged because this quantum revolution, it's just beginning. Who knows what incredible discoveries are waiting for us, Thanks for joining us on the deep dive.